Now, the exact same information can be represented in an equivalent table. So if we let 4 years in prison be equivalent to 0 years of freedom, so spending 4 years in jail, that's the maximum punishment. It is the same as having 0 years of freedom. Then 3 years in prison is equivalent to 1 year of freedom. 2 years in prison is equal to 2 years of freedom. And no years in prison is equal to 4 years of freedom, and so on. So we get the following table. So confirm that it is equivalent to the previous table. So if P1 betrays and P2 remains silent, then the payoff to P1 is +3 and the payoff to player 2 is 0. It is the same as this entry. If P1 betrays and P2 remains silent, P1 spends 1 year in jail, so the loss of 1 year of freedom, and P2 spends 4 years in jail. 4 years in jail means 0 years of freedom. 1 year in jail means 3 years of freedom. So that is equivalent to this payoff, right? So this table, the information contained in this table and the information contained in the previous table are exactly the same. Now, when information is represented in tables or matrices, it is called a normal form representation. But there is another way of representing the exact same information using what is called a game tree. In the game tree, these solid lines are called branches. The beginnings of the solid lines are called nodes. The end of the nodes are called terminal nodes. This is an initial node. This is an intermediate nodes. These are terminal nodes, and these are branches. And the whole game is called a game tree. This way of representing a game is called an extensive form representation. And the dashed oval around player 2's indicates that player 2 is unaware or not aware of player 1's actions. So player 2 does not know whether player 1 has betrayed or has remained silent. Once again, the first entry in brackets always represents the payoff to player 1. So you should confirm that the information contained in this diagram is the same as the information contained in this table, right? We are sticking with positive numbers. So let's deal with positive payoffs then. Now, think about what the prisoners might do. Neither is aware of the other's actions. If both prisoners remain silent, the payoff is highest for them both jointly, 2 and 2. But there is no guarantee that the other prisoner will remain silent if one of them is silent, right? So if I am a prisoner and I remain silent, there is no guarantee that the other prisoner will also remain silent. If I am silent and the other prisoner betrays me, then he will get a payoff of 1, or he will get a payoff of 3, and I will get a payoff of 0. So there's always a risk of remaining silent. Silent is good if the other player also remains silent, but there is no guarantee. Now, if player 1 betrays and player 2 is silent, player 1 is better off. Player 1 gets a payoff of 3, and the other player gets a payoff of 0. On the other hand, if player 2 were to betray, player 1 is still better off, because if both betray, they both get a payoff of 1. Because if the other player had remained silent, the payoff would have been 0-3. The first player would have got 0, and the other player would have got 3. And the same logic applies to player 2. Betrayal always guarantees an extra year of freedom. Betrayal is therefore a best response strategy. spend as much time as you need completely understanding the mechanism and the actions and the payoffs of the game, and why betrayal is the best response strategy. So when we have a payoff matrix, we can underline best response strategies. What does that mean? Underlining best response strategies means you underline the highest payoff against the other player's action. So the other player takes an action, either betray or silent. Against the other player's action, you will get a payoff. What is the highest payoff? You underline that. Okay, so start with player one. If P1 betrays, what is P2's best response? The best response would be the one which yields the highest payoff against P1's action, and we underline it. So when P1 betrays, what should P2 do? If P2 remains silent, his payoff is 0. If P2 also betrays, his payoff is 1. 1 is bigger than 0, so the best response for P2 is to also betray. If the player 2 were to be silent, that does not represent a best response if P1 plays betray. Moving on, if P1 is silent, what is P2's best response? Again, the best response would be the one which yields the highest payoff against P1's action, and we underline it. So now P1 is silent. If P2 were to betray, he would get a payoff of 3. But if he were to remain silent as 1, he would get a payoff of only 2. 3 is greater than 2. So P2 would betray if P1 remains silent. Remember, the second entry in the cells is always the payoff to the second player. Okay? So when P1 plays silent, P2 should play betray and get a payoff of 3. If P2 had played silent instead, he would have received a payoff of 2. Therefore, silent does not represent a best response if P1 also plays silent. Now we repeat the process with player 2. Okay, we repeat the process with player 2. If player 2 betrays, what is player 1's best response? The best response would be the one which yields the highest payoff against P2's action. We underline it. And if P2 betrays, P1 should also betray, because if P1 remained silent, his payoff would have been 0, but by betraying, his payoff is 1, which is higher than 0. So you underline it. Okay? And then we move on. If P2 is silent, what is P1's best response? If P2 is silent, P1's best response would be the one which yields the highest payoff against P2's action. And so this time, if P2 is silent, P1 should betray and get a payoff of 3. If P2 is silent and P1 remains silent, he would only get a payoff of 2. Right? So the best response of player 1 to player 2 is silent, is betray, I beg your pardon. The best response of player 1 to player 2 when player 2 is playing silent is betray. So after we have played the game, notice that the best responses of both players against the other player's actions mean that we have underlined both the payoffs in the cell corresponding to betray, betray. So whenever you have a double underline in a cell in a 2-player game, that cell would represent an equilibrium, And the strategy against those payoffs is called a best response strategy. In this particular case, it is also a dominant strategy. So the best response, small si, is a best response for player I to rival strategies S not I, which is denoted S not I being included in the set BR sub I of S not I. If the payoff of SI S not I is greater than or equal to the payoff of SI prime S not I for all SI prime belonging to capital SI. So a best response strategy is the one that gives you a payoff which is greater than or equal to any other payoff for all other strategies SI prime contained in capital SI. And a dominant strategy is a strategy SI star for player I that is a best response to all strategy profiles of the other players. So SI star will be contained in or will be a member of BR sub I S not I for all S not I. Right, so the dominant strategy is a strategy for player I that is a best response to all strategy profiles of the other players. Now we introduce very important equilibrium concept in economics called Nash equilibrium. A Nash equilibrium is a strategy profile S1 star, S2 star, all the way up to Sn star. So notice that these are starred strategies, so they are best responses, such that for each player I equals 1, 2 to n, Si star is a best response to the other player's equilibrium strategies, S not I star. So whenever you play your best response to the other player's best response, that would be a Nash equilibrium. Okay, when you have two players, the Nash equilibrium is S1 star, S2 star. If S1 star and S2 star are mutually best responses against each other. Okay, so the payoff of playing S1 star, S2 star is greater than the payoff of any other strategy S1 given the other player is playing S2 star. Similarly, the payoff of player 2 when he plays S2 star has to be bigger or greater than or equal to the payoff of playing any other strategy S2 when the other player is playing S1 star. Now there's a slight difference between a Nash equilibrium strategy and a dominant strategy. A dominant strategy is a best response to all other strategies, including Nash equilibrium strategies. If all players in a game have a dominant strategy, we say that the game has a dominant strategy equilibrium. In the prisoner's dilemma game we just saw, betray was a dominant strategy, as well as a Nash equilibrium strategy, because there were two players and they were both playing their dominant strategy or best response against the other player. Okay, so I will end the video